Hey folks, great you're watching again and welcome to this English summary. This morning we started with unboxing the Indie Night Vault because there were some things delivered which we needed, and especially the bolts and plugs to fit the pressure vessel for the compressor to the wall. Yeah. Atlas Copco is coming next week to install a screw compressor and also a pressure line in the workshop. But in preparation we needed to put this pressure vessel somewhere, and I thought it would be a good spot to put it there on the wall. So yesterday we made the support brackets. Today we assembled it to the wall. At first I wanted to use the plugs on all three positions on the brackets, but I didn't trust the plugs for putting such a load on. So therefore I drilled through the wall. I used a threaded rod and with a plate on the other side and just a nut. So we can be sure that it won't be pulled off. That's pretty I think that's a good thing. It's not nice if you're working here and then the thing come falling down. Okay, good. I think I don't need to explain anything about the process about putting it there, but afterward we explained something about levers and forces. For the explanation why this part is longer and why the threaded rod is at the top of the bolts, and why that one is most important. Okay, well, good. We did a simple explanation about the levers. If you have, I'm thinking of we should explain it over there. Let's do that. Well, if you have a lever like this and you have a hinge in the middle there, and you have a force over here, 50 kilograms over there, and you have a force over there, and this is balanced, right? That's important. Then this force is also 50 kilos. Good. I explained it in kilos, kilograms. If you are calculating with forces, you should use newtons. But to keep it simple, I just calculate it in kilos. That's most easy for everyone, I think. Good. But now, if we make it like this, I slide the hinge over there, and it's on a third, so this is 1 meter, this is 2 meters. Then what is this load? It's pretty easy. You have to calculate the torque in the hinge point, and the torque is just the force multiplied by the arm. So it's the force multiplied by the arm is the torque. So in this case it's 50 multiplied by 1 is 50. It's 50 kilogram meters, right? So that's the torque over there. This force also results in the same torque, because it's a balanced situation. The torque should be, it should be zero, the complete thing, right? Good. Then we have a force multiplied by the arm is the torque. We know the arm because that's 2 meters. We know the torque, so then we say 50. That's divided, David? I'm not sure. Divided by 2, so is 25 kilograms. So the force over there is 25. Well, that's how a lever works. So that's pretty simple. the most difficult part for levers can be seeing where the hinge point is, what the length of the lever is. Well, we have this situation. This is the pressure vessel, 150 kilograms. It's supported by two brackets, so that's 75 kilograms each. Then we have the side view of the construction. This is the pressure vessel, 75 kilograms. And then we have to think where the hinge is in this situation. And the hinge is at the bottom there. If these bolts would snap, it starts hinging like this, because there are some extra bolts over there, but it will, the pulling force over here, which keeps the thing in position, well, it finds its hinge over there. The arm, the length of the arm is always perpendicular to the force. So we have 75 kilograms and then 35 centimeters. So that's the arm and the force. Then you just multiply 75 by 35. This will give you the torque in this hinge. Well, then we have the second arm is over here, and that's 76 centimeters. And just by multiplying these two and then the result divided by this, it will give you that force. And then we get 35 kilograms. That's how hinges work. So it's not that difficult. The most difficult part is seeing where the arms are and where the hinge is. That can be the biggest problem. And of course, this is very simple. We have a few forces over there. We have more bolts, so this load is spread over those bolts. So then it becomes more complicated, but I keep it simple. Just but one force there, one hinge there, and one force there, and then you have two levers. That's about it. Good. Then we start working on the small ATV, because it's still sitting in the workshop and it did not run pretty well. We measured the compression on it, and it was pretty low. So we pulled the cylinder and find out the cylinder and piston are scorched. So, well, that's not good. So we are going to exchange that. So I have to get another piston for that. We had some spare cylinders. We found out there was some difference between those. That's pretty obvious. So pretty weird. See this. This is original Suzuki, and this is I guess Linmax. That's another make. It's a clone or something. I'm not sure, but that's different. We have exhausts which fit both of the cylinders, so it doesn't really matter which one we use. So, good. Well, and then the good news is we are going to René's diesel service tomorrow with the fuel pump of the BMP and also the injectors. So we are going to get it tested. I'm curious about the results, and I'm curious if they can fix it in the testing bench, because it's a pretty weird pump. It's in fact it's a line pump, but these are two line pumps using one camshaft in the middle. So, normally you have just a line pump with everything in line, and I'd like to. So it's a special thing, but they will manage. And of course, we want to see if we can get those working, the injectors, because the atomizers, the small holes in the tip, many of those are clogged. So I hope they can clean it with the ultrasonic cleaning device, and I hope that will solve it. Otherwise, we have to replace either the nozzles or the entire injectors. Good. And that's about it. So I would say thank you for watching. and see you next time.